Hi, in this video, we are going to begin our discussion of hyperbola. We have so far covered parabola and ellipse, and we'll go to hyperbola now. It is a similar curve, just a few details that are different from the last two conic sections that we have seen. So let's begin by understanding the basic locus definition of a hyperbola. It is locus of P such that PS by PM is equal to E, where E is greater than 1. And here PS is obviously same as before, distance of P from fixed point S, where S becomes your focus, and PM is perpendicular from P to the directrix line, which is the fixed line that is given. Fixed line. That becomes your PM. So if the ratio of these distances is equal to E, the E is your eccentricity, and this constant ratio should be greater than 1. In that case, this curve, the locus of P, is called a hyperbola, right? So if you have a general 2-degree equation, which looks like this, py square plus 2gx plus 2fy plus c equals 0. In this case, if you have to identify a hyperbola, first of all, the discriminant for this should not be equal to 0, and h square minus ab should be greater than equal to 0. If these two things happen, then this curve, this 2-degree equation represents a hyperbola. So just like in an ellipse and a parabola, for parabola, this was h square minus ab was equal to 0. For ellipse, it was negative. By hyperbola, it is positive. So let's go to the standard equation of a hyperbola. The standard equation looks like this: x square by a square minus y square by b square is equal to 1. This is the simplest form of a hyperbola, or the standard form. And here the curve looks somewhat like this. This is my origin. The focus are at these points AE comma 0. This is first focus. S2, second focus is minus AE comma 0. And the directrices are somewhere here and here. These lines are basically x is equal to A by E and x is equal to minus A by E. So notice that the directrix now is inside and the curve is on the two different sides. So this is the general hyperbola equation. P is a variable point here. So you have PS1 is equal to E times PM1. So this is your PM1 and this is your PS1. So we can write PS1 is equal to E times PM1. And similarly, for the same point P, you can say that PS2 is equal to E times PM2. So this is your PM2 and this distance becomes PS2, right? M1, by the way, I have marked incorrectly. PM1 would be here. This is PM1, right? So these are perpendicular distances from the point to the directrices, and this is the relation. So when we look at the general equation of the hyperbola here, the eccentricity is given by E square is equal to 1 plus b square by a square. And these points are the points minus a comma 0, the vertices, and a comma 0. And there are two other points on the y-axis which are at 0 comma b and 0 comma minus b. So these are the endpoints of the transverse and the conjugate axis. Now let's try and understand some of the basic properties of this equation. X square by a square minus y square by b square equals 1. So first of all, you should realize that if xy belongs to the curve C, let's call this as the curve C. So if xy belongs to curve C, it implies that minus x comma y and x comma minus y also belong to C. So basically the curve is symmetric about both the x and y axis. X and y axis. Then the second point here you should realize is that if xy belongs to the curve, it also implies that minus x comma minus y belongs to the curve. So this means that the curve is symmetric about the origin as well. Symmetric about the origin. Right. This also means that for every point xy, there is a corresponding point minus x comma y minus y on the curve, which means that the origin is the center of the conic, center of the hyperbola, because any chord passing through the origin will be bisected at 0, comma 0. So origin bisects any chord passing through it and connecting 2 points on the hyperbola. So hyperbola is also a central conic, and this is your center, 0, comma 0. Now, so what you can say is if xy belongs to C and y is equal to 0, then from the curve x square by a square minus y square by b square equals 1. If you put y is equal to 0, you get x square is equal to a square. So x is equal to plus minus a. So there are 2 points where the curve meets the x-axis in 2 points. And these 2 points are known as the vertices of the hyperbola. Vertices of the hyperbola. And basically these are points A, which is a comma 0, and point A dash, which is minus a comma 0. These 2 points are the vertices of the hyperbola. And this axis, the line joining A and A dash, the axis A dash is called the transverse axis. Called the transverse axis of the hyperbola. The length of the transverse axis is clearly 2a. Length of transverse axis is equal to 2a, right? It is the line segment joining this point and this point. And this is the point where the curve cuts the x-axis, right? Now, let's think about if xy belongs to the curve and you have x square by a square minus y square by b square equals 1. And then you say, let's put x is equal to 0 in this. If you put x is equal to 0 in this, you'll get minus y square by b square is equal to 1. So y square is equal to minus b square. And that means that y is imaginary. So basically, you do have no real points where the curve cuts the y-axis. The curve does cut the x-axis at 2 points, as we saw previously, but the curve does not cut the y-axis at any real point, right? The points B, if you think here, y can be written as IB and minus IB, right? And if you think of the complex plane, this is my imaginary axis. You can mark 2 points, 0, comma B and 1 point 0, comma minus B. They will represent the points IB and minus IB, right? So the points B, 0, comma B and B dash, 0, comma minus B are 2 points on the y-axis, which you can think of as the imaginary intersection of the curve with the y-axis, right? So these are imaginary points of intersection of the curve and the y-axis, right? So this axis B dash is known as the conjugate axis. Conjugate axis, and the length of the conjugate axis, length is equal to 2b, right? So this becomes your 2b, and that is the length of the conjugate axis. The focus of the hyperbola are on the transverse axis. Focus are on transverse axis, and they are the points AE comma 0 and minus AE comma 0. Just like in the ellipse, the directrices are also parallel to the y-axis, and they are at x is equal to a by e and x is equal to minus a by e. Again, just like in the ellipse, the only difference is that the e value is greater than 1 now and not smaller than 1, right? There is another special type of hyperbola which we will briefly discuss now, and then later we'll go into much more detail. A rectangular hyperbola is a special case of our general hyperbola x square by a square minus y square by b square is equal to 1 if a is equal to b. So the equation of the rectangular hyperbola becomes x square minus y square is equal to a square. And the eccentricity E becomes root over 1 plus b square by a square. But a is equal to b, so it is 1 plus 1, so it is root 2. So the eccentricity of the rectangular hyperbola is root 2 always. The rectangular hyperbola happens when the length of the transverse axis and conjugate axis are equal. Okay. Now let's look at a standard theorem which says difference of the distances of any point on a hyperbola is constant. In an ellipse, we saw that the sum of the focal distances was constant. In a hyperbola, it is the difference of focal distances that is constant. So how do we get that? So first of all, we mark everything. This is focus 1, AE comma 0. This is focus 2, minus AE comma 0. This is directrix x is minus a by e, and this is x is equal to a by e. And let's say my origin and the y-axis is somewhere here. This is 0 comma 0. Now, if I have a point somewhere here, this is my point x1 comma y1, let's say. So what I want to show is PS1 and PS2. These are my focal distances. PS2 minus PS1 modulus is a constant. That is what you need to show. Okay. So by the property of the hyperbola, PS1 would be E times PM1. This distance is PM1. And also this distance is PM2. The same perpendicular, right? So this much is PM2 and this much is PM1, right? Now PS1 is equal to E times PM1 by definition. Similarly, PS2 is E times PM2 by definition of a hyperbola. Therefore, PS2 minus PS1 is equal to E times PM2 minus PM1. Now think about it. PM2 minus PM1 is simply E times M2 M1. And M2 M1, the distance between these two parallel lines is actually 2A by E. So this becomes E times 2A by E. And what we are getting is PS2 minus PS1 is equal to 2A, right? Which is a constant because the A is a constant in the equation of the hyperbola, right? Also, this tells us a way to find the focal distance of any point on the hyperbola. So here PS1 is equal to E times PM1, and PM1, if you think about it, is x1 minus A by E. x1 minus A by E times E. So this is becoming EX1 minus A. That is PS1, right? So the focal distance PS1 is EX1 minus A, and the focal distance PS2 would be E times PM2, and that would be E times A plus A by E, right? because the focal distance PS2 would be distance till here, and that is equal to this, and this was at x is equal to minus a by e, and this was at x1 comma y1. So not a plus, it is going to be x1 minus minus a by e. So it is going to be x1 plus a by e. So this becomes basically ex1 plus a. So the focal distances of the 2 points on a hyperbola PS1 and PS2 are ex1 minus a and ex1 plus a, right? Remember, for an ellipse, it was a plus ex1 and a minus ex1. Focal distances on ellipse. And on a hyperbola, it is ex1 minus a and ex1 plus a. So that's why the difference of these two is equal to 2a. And in the ellipse, it was the sum of the focal distances that was equal to 2a. I hope you are understanding the differences. Similarly, focal distance on parabola was simply a plus x1. Because the eccentricity of a parabola is 1 and there are no two foci, there is only a single focus in a parabola. So there will be no two separate distances. There will be a single a plus x1 is the focal distance of point x1, y1 on a parabola. So these focal distances, all of these three need to be known, because many times you can solve problems directly if you do that. Another concept that you need to be aware of is the standard notation. So the equation of the hyperbola can be written as this equation: x square by a square minus y square by b square minus 1 is equal to 0. That can be called your equation S. So similarly, if I put a point in it, it will be S1. S1 would be if I put x1, y1 into this equation, and that would have been x1 square by a square minus y1 square by b square minus 1. That is your S1, right? Now there is another type of hyperbola which is known as the conjugate hyperbola. So the hyperbola whose transverse and conjugate axis, the definition is this: the hyperbola whose transverse and conjugate axis are respectively the conjugate and transverse axis, of a given hyperbola, is called the conjugate hyperbola. It's called the conjugate hyperbola of the given hyperbola. So what is the meaning of this? It is actually pretty simple, even though the definition looks long. So basically you have a hyperbola like this: x square by a square minus y square by b square equals 1. This is my hyperbola graph. This is my transverse axis. And this is my conjugate axis. The points here are the minus a comma 0 and a comma 0. And the points here are 0 comma b and 0 comma minus b. These are my transverse and conjugate axis. Now I can make another hyperbola like this, where the transverse axis and conjugate axis are reversed. So the conjugate axis of the original hyperbola is the transverse axis of the new hyperbola. Transverse axis of new hyperbola. And this axis becomes the conjugate axis of the new hyperbola, which was the transverse axis of the old hyperbola. So this is curve 2, and this was my curve 1. So this equation is this. This was my first equation. For the conjugate hyperbola, the equation is simple. Your x and y are interchanged, right? You can write this like this, or actually you can just say that it is x squared by a square minus y squared by b square is equal to -1. So basically it becomes y squared by b squared minus x squared by a square equals 1. This is the equation of my conjugate hyperbola. Here the y-axis is taking the place of the transverse axis and the x-axis is taking the place of the conjugate axis. That's the difference. Each hyperbola is, both of these hyperbola can be said to be conjugate to each other, right? Obviously the transverse axis here has length of 2b and 2a is the length of the conjugate axis. So these terms must be familiar to you. You need to understand what is happening here, right? Now, let's look at some of the other forms of the equation of a hyperbola. You can have a situation where, let's look at first the standard form, x squared by a square minus y squared by b square equals 1. Here, what are the information that we know from this? The center is 0, 0. Vertices are the points where the transverse axis meets the hyperbola. So those are a comma 0 and minus a comma 0. Now similarly, we can say transverse axis is x-axis. Conjugate axis is the y-axis here. Length of these axes are 2a and 2b. The eccentricity is root over 1 plus b square by a square. The foci are ae comma 0 and minus ae comma 0. The directrices are x is equal to plus minus a by e. And the length of the latest rectum is basically line through the focus which is perpendicular to the transverse axis. It would be 2b square by a. So basically it will be equation of the directrix would have been x is equal to ae or x is equal to minus ae. If you put that in this equation, you will get 2 points for y. The length of the latest rectum will come out as 2b square by a. So this is all the information that we know for the standard hyperbola. Now, if I have the conjugate hyperbola, which is x squared by a square minus y squared by b square is equal to -1. In this case, the graph looks like this. This is my graph. The focus becomes the points 0, BE, 0, minus BE. Center is still 0, 0. Vertices are 0, B and 0, minus B. The ends of the conjugate axis now are minus a, 0 and a, 0. The equation of the directrices are y is equal to plus b by e, y is equal to minus b by e. And the eccentricity E is root over 1 plus a square by b square in this case. Always you have to put the conjugate axis square first, semi-conjugate axis, and divided by the semi-transverse axis length, right? Remember in the earlier case it was root over 1 plus b square by a square. The length of latest rectum is also slightly modified. Length of LR, which would be this distance, would be 2a square by b. So that is all the information that you need about the conjugate hyperbola. Now, obviously, you can have a standard hyperbola that is shifted by some distance. This is basically a standard hyperbola whose center has been shifted to h comma k. So in a similar manner as earlier, you can, for the previous curves, parabola, ellipse also we have done this. So it should be familiar to you. So here what we will do is, we will say center is h comma k now. And what else do we know? We know that vertices vertices would be A plus H, comma 0, comma K, and A minus or H minus A, comma K. These are the vertices. It is on the y is equal to K line, and it will be H plus A and H minus A, comma K, right? Now, the transverse axis is the line y is equal to K. The conjugate axis is the line x is equal to H, right? Length of transverse axis is still 2a and length of conjugate axis is still 2b. So eccentricity is still root over 1 plus b square by a square. Eccentricity is still the same. Now equations of, first of all, let's find the foci. Foci will be at h plus minus ae comma k. This will be my foci, and directrix equations will be x is equal to h plus minus a by e. The length of latus rectum is same as before. It is 2b square by a. Okay. So these are important things that you need to know. Now, another form of the hyperbola sometimes that you might encounter is when the equation of a hyperbola is given with respect to two perpendicular lines. With respect to two perpendicular lines. So if you think of a regular hyperbola and pxy is a point on the hyperbola like this, x square by a square minus y square by b square is equal to 1. Think of the curve here. This is my origin. And think of this point px comma y on it, right? Now, if this distance is known as pm, the perpendicular on the transverse axis, and if this distance is known as pn. So what is pm? Perpendicular from p on transverse axis. And what is pn? Perpendicular from p on conjugate axis. We can see clearly that Pm is equal to y and Pn is equal to x. So the equation of the hyperbola can also be written as Pn square by a square minus Pn square by b square is equal to 1. Right? So think about this. This is a geometric relation between a point on the hyperbola and the perpendiculars from those points to the transverse and conjugate axis. And notice the form here. Pn was perpendicular on conjugate axis. Perpendicular on conjugate axis square is divided by a square, where a square is semi-transverse axis, minus perpendicular on transverse axis square divided by b square, which is semi-conjugate axis, is equal to 1. Now, if you have a situation where they have given you two perpendicular lines, let's say the lines are L1, which was A1x plus B1y plus C1 equal to 0, and L2, which was B1x minus A1y plus C2 is equal to 0. It is obvious that L1 is perpendicular to L2 from the equation itself. Now, let's say we need to find a hyperbola locus using these two lines. So we will drop a perpendicular Pn, and Pn is, let's say, the perpendicular to L1. That would be A1x plus B1y plus C1 by root over A1 square plus B1 square. And similarly, Pm was the perpendicular on L2, and that was B1x minus A1y plus C2 mod root over b1 square plus a1 square, right? Now, equation of hyperbola with respect to these two lines can be written as perpendicular on pn square by a square minus pm square by b square is equal to 1. And pn is this, pm is this. If you square it and stuff, you'll get a simplified equation of the hyperbola. Just put this data in it, you will get the equation of the hyperbola. Here, the center would be the intersection of L1 and L2. Intersection of L1 and L2. That would be the center. Here, the transverse axis would be along the line transverse axis. So PM was a perpendicular on the transverse axis, right? So the transverse axis would be line L2, which is B1x minus A1y plus C2 is equal to 0. Similarly, conjugate axis would be line L1, which would be A1x plus B1y plus C1 is equal to 0. The length of the transverse and conjugate axis will be 2A and 2B. The eccentricity will be the same as before. Now, the foci would be the intersection point of the transverse axis and the line. So, if the transverse axis is this line, and we know the center is basically intersection of L1 and L2, you can say that the equation of the foci will come. See, my conjugate axis was A1x plus B1y plus C1 equals 0, right? And my transverse axis was this line, B1x minus A1y plus C2 is equal to 0. So what we can say is that the perpendicular distance from the focus to this line should be plus minus AE, right? This will be my point S1, the perpendicular from here to this line. So we can say that A1x plus B1y plus C1 by root A1 square plus B1 square is equal to plus minus AE. That will give us the coordinates of S1 and S2, right? So that will give us my focus. And similarly, you can find the other things as well. Okay, now we look at one standard theory where if you have a hyperbola like this, which regions are considered interior to the hyperbola and which regions are considered exterior. So we will call this region interior and this region interior. The ones that are inside these curves. And this whole region is the exterior of the hyperbola. Right? Everywhere here, that is the exterior of the hyperbola. And how do we decide whether a particular point is in the interior or exterior of a hyperbola? What we can do is we can put the point P x1 y1 into the hyperbola equation x square by a square minus y square by b square minus 1 equals 0. If you put x1 y1 into this equation and the answer comes out as negative, or basically s1 is less than 0, then it is interior. If S1 is bigger than 0, it becomes the exterior and so on. If S1 is equal to 0, the point is on the hyperbola. Right. Now, one more thing that we can discuss here. This is actually a question that has appeared in JEE mains as well. So we have if E1 square and E2 square are eccentricities of two conjugate hyperbolas, conjugate hyperbolas, then we can show that E1 square plus E2 square is equal to E1 square E2 square, or 1 by E1 square plus 1 by E2 square is equal to 1. So what does the question mean? So let's say two hyperbolas that are conjugates of each other. This is my standard hyperbola, and the conjugate would be x square by a square minus y square by b square is equal to -1, right? This is my conjugate hyperbola. So what is the eccentricity here? If you call the eccentricity of this one as E1, this is root over 1 plus b square by a square. And if you call eccentricity E2 for this one, this is root over 1 plus a square by b square, right? Okay, so now we have to just show that this property is true. E1 square is equal to 1 plus b square by a square, which is a square plus b square by a square. That is my E1 square. And similarly, E2 square is 1 plus a square by b square, which is clearly a square plus b square by b square, right? And now from these two, it is obvious that if I do 1 by E1 square plus 1 by E2 square, what will I get? 1 by E1 square is equal to a square by a square plus b square, and 1 by E2 square is equal to b square by a square plus b square. And it is clear that 1 by E1 square plus 1 by E2 square is equal to 1. So this is a very nice result that connects the eccentricities of two hyperbolas that are conjugate of each other. If you know that, then given the eccentricity of a normal hyperbola, the eccentricity of its conjugate is obvious, right? Okay. Now let's do a couple of questions. So I want to do a couple of questions. So here, first question is, find the eccentricity, focus, foci, length of latus rectum, and equation of directrices. Equation of directrices to this equation of the hyperbola y square by 9 minus x square by 16 is equal to 1. So clearly, this equation can be written as x square by 16 minus y square by 9 is equal to -1. So this is a conjugate hyperbola. You can see that there is a -1 here. This is a conjugate hyperbola. And as we saw earlier in the theory, it will look like this, the conjugate hyperbola, right? And the normal transverse axis is now the conjugate axis for this. The center of the hyperbola is obviously going to be 0, 0. The eccentricity would be root over 1 plus a square by b square now. So that becomes root over 1 plus 16 by 9. So that is 25 by 9 or 5 by 3. That is my eccentricity here. Now latus rectum, length of latus rectum is 2a square by b, not b square by a here. So 2 into 16 by 3. So latus rectum length is 32 by 3 here. Now what are the foci? Foci, as you know here, it is reversed and it is 0 comma be and 0 comma minus be. So b is 3 and e is 5 by 3. So it will be 0 comma 5 here, and this would be 0 comma minus 5. This becomes your foci. The equation to the directrices would be y is equal to plus minus b by e. Y is equal to plus minus b by e would be what? 3 by 5 by 3. So plus minus 9 by 5. That becomes the equations of the directrices, right? So this type of question you need to be very comfortable with doing. Let's look at another problem. Find the foci of the hyperbola 9x square minus 16y square plus 72x minus 32y minus 16 equals 0. So if the equation is given in this form, your first step should always be completing the squares. So you can do 9 times x squared plus 8x. This covers this term and this term. And minus 16 times y squared plus 2y is equal to 16. And here, what constant terms do we need? So we need a 2 into 4x. So we need a 2x into 4. So we need a 16 here inside. So you have 9 times x squared plus 8x plus 16. You have to do a minus 144 now. Minus 16 times y squared plus 2y plus 1. So you have to do a minus 16 here is equal to 16. So you're getting 176. You are getting basically a minus 160. So 176 on the other side, I think. Right. Oh no, here we have to do a plus 16 because there was a minus sign here. We have added a plus 1, but it's actually a minus 16. So I have to do a plus 16 here. This 16 gets cancelled with this, and I get a 9 times x plus 4 whole square minus 16 times y plus 1 whole square is 144. And this becomes x plus 4 whole square by 16 minus y plus 1 whole square by 9 is equal to 1. This is my standard hyperbola. And now it is easy to find the foci because the center has been shifted to minus 4 comma minus 1 and it is a normal hyperbola. So foci would be h plus minus ae comma k, right? And h is minus 4 plus minus a is 4e comma k is minus 1. So we have to find eccentricity. Eccentricity E is equal to root over 1 plus b square by a square. So 1 plus 9 by 16. So that becomes 25 by 16. So 5 by 4. So you put 5 by 4 here for eccentricity. You get plus minus 5. So it is going to be 1 comma minus 1 and minus 9 comma minus 1. These are the two foci. H plus minus. I feel like I'm making a mistake here. Center is minus 4 minus 1. So minus 4 plus 5. Right. So the focus is x plus h is equal to plus minus ae and y plus k is equal to 0. So plus minus ae minus h, right? So we have basically x plus 4 is equal to plus minus ae. So 4 times 5 by 4. Okay, I'm correct only. These are the foci, right? Okay. Next, the other things that we need to do here is, first of all, there is equation of tangent to hyperbola x square by a square minus y square by b square is equal to 1 at the point P x1 comma y1. By the replacement method, we can directly get equation of tangent is this x1 minus y1 by b square equals 1. This becomes my equation of tangent. And again, if I want to do it in a different form, if I want to see y is equal to mx plus c line is tangent to hyperbola, that can be done by using the method of quadratic equations. So we'll solve the line with the hyperbola curve. And if we solve it, we will put discriminant equal to 0. And that will give us the condition on the c constant. And you should get c square is equal to a square m square minus b square. This is the condition for tangency. And here m is the slope of the tangent, and equation of the tangent is y is equal to mx plus minus root over a square m square minus b square. So notice that this equation is very similar to the equation of tangent to the ellipse in slope form, right? So that should be something that you know. Similarly, if I have a different form of the line equation, if you have to say that Lx plus my plus n is equal to 0 is tangent to hyperbola x square by a square minus y square by b square equals 1. Again, the method of doing it is the same. Take this equation, solve it with this curve, and put discriminant equal to 0. The condition for the discriminant to be equal to 0 will come out to be this: a square l square minus b square m square is equal to n square. This is the condition for tangency. Remember, for ellipse, it was a square l square plus b square m square is equal to n square. Even if you don't remember, it is going to be fine. But if you remember it, it will be faster for you in problems, right? So these are things that you need to know. Then again, another point is that from an external point of an hyperbola, from an external point on a hyperbola, you can draw two tangents. You can draw two tangents to the curve. Two tangents to the curve. Similar to what we did for parabola and ellipse, so nothing major here. Let's look at the equation of normal at a point. So equation of normal at x1, y1 to x square by a square minus y square by b square is equal to 1. So first of all, the tangent equation was this. This was equation of tangent. So from here we can get the slope of the tangent. Slope of the tangent is minus x1 by a square divided by minus y1 by b square. So it is b square x1 by a square y1. This is slope of tangent. So slope of normal would become minus a square y1 by b square x1. And now equation of normal would be y minus y1 is equal to minus a square y1 by b square x1 into x minus x1. And we can simplify this equation and remember that x1 square by a square minus y1 square by b square is equal to 1, because x1, y1 is a point on the normal, right? So using that, you will be able to show that the equation of normal comes out like this. The equation of normal to a hyperbola can be written as this: a square x by x1 plus b square y by y1 is equal to a square plus b square. This is the normal at x1, y1. The proof of this is simple. Use this, simplify it a little bit. See, you'll get b square y and stuff, and use this result also, because point x1, y1 lies on the curve, right? So that gives us the equation of normal. Now, what we will be doing in the next class is some more advanced theory, and then the parametric form of a hyperbola and the theory about rectangular hyperbolas. So one more class of theory is required. All of this stuff that we discussed in today's class should feel very familiar to you, because we have recently done parabola and ellipse in great detail. So all of this should be familiar. You should make notes for what we have learned today and wait for the next class where we'll try and finish the theory for this chapter. And after that, we'll do a few problem solving sessions as well. So that's it for this video. If you like the content, please like the video and subscribe to the channel, and I'll see you next time.